Hi, I'm Rob Mickelson, the Director of Agronomy for Yara in North America. And today I'd like to have a quick overview with you that shows that almost all of our common crops have a physiological preference for nitrate nutrition. So the goal of Yara is to provide that crop nutrition in the form that best meets the needs of plants so they can reach their full potential. Nitrogen is the most commonly added fertilizer for crop production, but the fertilizer is available in different forms. Today I want to focus on the preference of plants for nitrate or ammonium in their growth and development. In particular, does the source of nitrogen really matter? Let's review that when plants take up either ammonium or take up nitrate, their immediate response is very different. One of the first things we see is that the ionic charge of the nitrogen molecule, be it positive or negative, makes a big impact. Plants that take up mostly negatively charged nitrate will need to excrete negatively charged hydroxyls to maintain their internal electrical balance. When plants are fertilized with positively charged ammonium, plants excrete positively charged protons or hydrogen to maintain that internal ionic balance. This causes the soil around the root to become acidic. The metabolic processes of nitrogen uptake and assimilation are a bit too complex for today's discussion, but I'll address that a bit more at the end. Let's just summarize that nitrate gets into the root using energy through a proton pump, and then it becomes converted to ammonium through two enzymes, primarily in the leaves, but also in the roots. In the photo on the right, you can see the purple color that's showing the alkaline condition around the roots fertilized with nitrate. Ammonium, of course, is also taken up by roots, but it must be assimilated while it is in the roots. Ammonium is toxic if it accumulates in the plant. So the photo on the left shows the yellow color, indicating the acid conditions or the protons being excreted around these roots of wheat. Now, I want to show some results from the excellent work that Yara has been supporting the past couple of years with Dr. Dharma Pichai at Tennessee State University. Let's go through some of these results we've been discovering. Here is a photo showing various nitrate and ammonium ratios provided to almond trees, a very important crop in California. You can clearly see the negative effect of ammonium on tree performance. Here we have trees with 100% nitrate nutrition on the left, and then a greater proportion of ammonium as we move to the right. Clearly, the size and health of almond tree branches is also easy to see as the proportion of ammonium increases as you go to the right. Then we looked at the nitrogen source preference of other tree species in the same Rosaceae plant family, in this case apricots. Apricots behaved in the exact same way as almonds, in that they couldn't tolerate ammonium in the root zone before their growth suffered. Then we looked at tobacco plants because this is a crop that we've been told has a strong preference for nitrate. So as the proportion of ammonium increases, the plant performance clearly decreases, just as we had suspected. And a closer look at the tobacco leaves showed the same trend, as do the tobacco roots. In this Yara-sponsored project with strawberries, we see the same negative growth response to ammonium nutrition. Now I could go on with more examples, but here's just a few that I selected from the scientific literature. In this case, watermelon seedlings were stunted by the presence of almost any ammonium. Tomato growth decreased as the proportion of ammonium increased in the root zone. And can you see the lesions that are starting to develop on the roots of tomatoes fertilized with ammonium? Cannabis growth and quality drops as the proportion of ammonium increases in the root zone. Avocado growth was best with nitrate nutrition alone. Now I could go on with many more examples from the literature, but I think you get the idea by now. The evidence is clear. A nice review paper was recently published in the journal Field Crops Research, where the authors used over 2,400 scientific observations to group plants into 3 categories. Now, rice is in the group that prefers ammonium. That also includes blueberries and cranberries. Wheat is in the category that preferred a mixed source of nitrogen nutrition, but then almost all other crops were grouped as plants that perform best with nitrate nutrition. So we see that an excess of ammonium causes significant plant stress, including inhibition of cation uptake, such as potassium, magnesium, calcium, and that can change the internal plant ion balance. It alters cellular pH. Too much ammonium inhibits plant respiration and disrupts photosynthesis. Ammonium in excess can negatively modify enzymes and cause imbalances in plant hormones. Oxidative stress increases in the plant, and there's a general elevated energy expenditure. So this quick overview today illustrates that almost all agricultural and horticulture crops have a physiological preference for nitrate nutrition. So the goal of Yara is to provide the necessary crop nutrition in the form that meets the needs of plants and allows crops to reach their full potential. The Yara Leva line of nitrate-based fertilizers are really ideally suited to meet this goal of optimal plant nutrition with a nature-positive food future. So if you'd like more information, please reach out to your local Yara representative for help. Thank you.